Hello guys, welcome to the next lecture of this particular thing. In the last lecture, we are discussing about the measures of dispersion or spread. In this, we discussed about the what is range and what is the concept of percentile. We discussed in the last lecture. Now we have to discuss about the very third measures of central dispersion. Third, that is quartiles. Quartile is very important for outlier detection. It is very important, quartile. So what is quartile? So now I will explain in very simple words what quartile does. Quartile. So what quartile does is, let's say you are having the data. What is your data? Let's say we are taking 6 rows: 10, 20, 30, 40, 50, 60. Okay, we are taking this particular data. Okay, now, in this data, what is quartile? Quartile will divide the data into four halves. Divide divide data into four halves or four parts. So, what are the four parts data is divided? Data is divided into 25 percentile, 50 percentile, 75 percentile, and 100 percentile. So like this the data has been distributed. So when I say about, so how does this work? Let's say if this is your data, okay, where you have entered these six values: 10, 20, 30, 40, 50, 60. So the 25% of 60, like how many, what is the n value? N value is your 6. Okay. So to find the percentile of, if you want to find the 25 percentile, in the last lecture we discussed one formula, right? Exclusive formula or inclusive formula we discussed. So what we will do, we will use the this we will use this uh, any formula we can use. Like we will be going to use the inclusive formula, let's say. Inclusive formula we'll use. So inclusive formula means what? 6 minus 1 into 25 by 100 plus 1. 6 minus 1 means what? 5 into 25 by 100 plus 1. Here means what? Here you got, if you divide 25 by 100 means 1 by 4 you got. So what is your value? 5 by 4 plus 1 means 9 by 4 you got. So 9 by 4 you got means something 2 point value you got, like 2.1 you got, let's say. So it means 1 0 2.2 you got, sorry. So this is your value, means this value, what you will do, you will take this seal of it, means third value. So out of this particular 6, sorry, you will take the floor value, not seal value. You will take the floor value. So that is 2. So what is this 2? This 2 means your second value. This second value is nothing but your 25 percentile data. Means the data from 0 till 25 is called as 25 percentile of data. So what is this 50 percentile of data? Means near around here you will get the 25 percentile of data. By default we claiming it as the 20, but it should be 22. Actually it should come here like this till here the data should be coming. So what does this mean? This mean that the 20, we are assuming 28 to be 25 percentage of 25 of data. So what is 50 percentile of data? The half of the data. So here you know, right, here the it is in sorting order, you can apply the median here. So if you apply 30 plus 40 by 2, you will be getting 35. So this 35 is nothing but your 50 percentile of data. It is also called as the median. Okay, median. 50 percentile of data is also called as the median. So what is the 75 percentile of data? Same, if you do this 5 into 75 by 100 plus 1, means what here 5 25 3 15 by 15 by 4 means what you are something 3.8 you will get, plus 1 means what 4.8, 4.8 means what 5 you will get. So this data till here 50 is nothing but this 75 percentile of data, and the last from 0 till 0 till 60 it represents the 100 percentile of data. Means what 25% of data means what from 0 till 25 data is comes under 25 percentile of data. From 0 to 50% data means comes under 35%. From 0 till 48 or 50 is comes under 75 percentile. From 0 till 60 means 100 percentile of data. So like this your quartile works. Quartile will work like this. So what are the quartile? Quartiles are the specific percentiles that split into ordered into four equal parts, providing key insights into data distribution. So Q1 means what? First quartile means 25 percentile means 24% of data falls below this value. So means what? 25% of data the below values comes under this range. 50 percentile means what? Middle value of the data set means median. Q2 is also called as the median. Q3 means what? 75 percentile means 75% of data falls below this value. So here we gave this particular calculation example, quartile calculation. To calculate this particular example, we take the n value as 9. Let's say it has used the exclusive approach. Exclusive approach. Okay. So what is the exclusive approach that it has used? If you calculate this R value, you got it as 2.5, means you can select 2 or 3, any value you can able to select, but you want the exact value that you want. Means that this 2.5 means what here between 7 and 8. So either 2, either 3 means 7 or 8. So you apply interpolation, and interpolation if you apply the interpolation formula you will get this value as 7.5. Means what the values from 5 to 7.5 comes under 25 percentile. Okay, this is your first quartile value Q1, which is also called as the like this you can calculate for Q2 also. Q2 means what you are 50 by 100 into 10 means what you get 5. So the fifth value like 1 2 3 4 5, the 14 will be from 5 till 14 will be your 50 percentile value. Similarly, if you want to calculate for 75, 75 by 100 into 10 means what you will get 7.5 means either 7 or 8, either 7 or 8 you got. So 7 or 8 means 1 2 3 4 5 6 7, 21 to 25 you got. So here you will apply the formula Q3, that is 21 plus what is that p value, what is the difference of p value that you got? 7.5, right? So 7.5 minus 7 means what? Zero point 0.5 you got into x of c means 25 minus 21 means 4 you got. Okay, so you got this value 21 plus 5 by 5 into 4 10 20 20 by 2 10. So 10 means what you got this value as 2. Okay, so means 23. This is your exact value of Q3. So from 5 till 23 is your 75 percentile of data. So this is how your quartiles have been calculated. So next thing comes is variance. What is variance? See, I will take one example to explain you variance. Okay, so what is variance? So I will take one variance. So what does this variance do? Let's say you are having this distribution and you have drawn this plot like this. Okay, and now let's say this point is your mean or median or any central point. This is your central point. Here I will write it as mean. So now if you see this, now let's say if you are selecting one particular point, let's say this particular point, how much this point is away from the mean, how much point this is away from the mean, how much sum of square value difference is the distance between mean and this point, will this the difference between the value of this point and mean point and mean. The two sum of squares is known as variance. Okay, so what does this variance will tell? This variance will tell how much this particular value is been there. But if you use variance, the problem with using variance is here the unit of var is not same as unit of data. So that's why calculation of variance will become very hectic in the data. That's why you won't be using the variance. But to use standard deviation, we use standard deviation. So to use standard deviation, variance is the key, because under root of variance will come your standard deviation. So now to calculate variance, what is the formula for us? So to calculate the variance, we will be using this particular formula. There are two formulas. One is for population variance, one is for sample variance. So as I already told you, what is population, what is sample? I'll again tell you this thing. Let's say if your data has, let's say, 3 points, 3, 4, 5 points. So this is the total data, means entire data, means population. So now what you will do, you want that out of this 5, I only want some data to be there with me. So what I will do, instead of this selecting all 5, let's say I selected this data and this data is selected. So these 2 points will come like this. This is nothing but sample. Means out of the entire data you are taking some samples. This is what population and sample. So to calculate the variance of population variance, if you want to calculate, you will use the formulas as this one: 1 upon n summation of I equal to 1 to n xi minus mu the whole square. This is how to calculate the population variance. To calculate the sample variance, we will be using 1 upon n minus 1. Same formula, 1 I equal to 1 to n, and here you will write xi minus mu the whole square. This is how to calculate the sample variance. I hope this particular thing is clearer to you. So now how to calculate this thing? Let's say you are having this data set. Okay, this data set. Obviously, the center value is mean. 4 plus 1 plus 10, if you take it also 21 by 3, you got the mean as 17. So now we will take this example. Okay, let's say data. Here I'll write 4, 7, 10. So to calculate this, first you have to calculate the mean. So to calculate the mean, what I told, sum upon n means 21 by 3, that is 7. So your mu is nothing but your mean. Okay, mu. So now what you have to do, you have to calculate xi minus u the whole square. So what is n? N is your 3. So 1 upon 3. In this, what you will do, first we will take 4. What is your mean? 7. So 4 minus 7 the whole square plus 7 minus 7 the whole square plus 10 minus 7 the whole square. If you calculate it, you will get the value as 1 upon 3. And now if you go 3 square 9, 3 square 9. If you do it, you will be getting the value as 18 by 3, which is nothing but 6. And this variance is represented as sigma. So the square of the variance, this is the value of calculating the variance. The sigma square is nothing but the variance. So like this, you calculate the variance of the particular data set. Since we are taking the entire data, that's why we use the population data. Now let's say if I want to take only 7 from it, only 7 I want to take, and to I want to calculate the sample variance of this data, then I will be using the below formula. So like this your variance works. Okay, means 7. So s square means you use this formula 3 square and 3 square 9 by why he has taken to, because he has taken this particular sample variance formula. So like this your calculation comes. So your variance is equal to 9, here variance is equal to 6, variance is equal to 6. So like this you can able to solve this particular thing like this. So now this is about population and thing. Variance measures the average square deviation from the mean, showing how spread out the data is from the central value. How much this data is spread out from the central value is represented as your variance. So now what is this? Now this comes the variance. Here I'll take screenshot and I will. I don't worry. I will add this screenshot also in description section, so you don't need to worry about it. So now what you have to do, now we'll explain the concept of standard deviation. Last topic to of our topic. So what is the standard deviation? I will take one example to explain you guys what is standard deviation. Same approach only. We'll take this example only. How much the data, let's say if this is your mean. So and we are, let's say, selecting this particular point. So how much distance is your mean from this particular point? Square root. Here the square root of how much the distance between point and mean is also represented by standard deviation. It is also called as STD. Variance we call it as, where STD stands for this thing. Now the we will be using the standard more. This is very very important compared to variance. Why standard deviation is important? Because here the units of data unit of data is equal to the value of standard deviation. Value of standard deviation. So now you always get this doubt, right? Why we use the standard deviation in place of variance? Because of this factor. The units of data is equal to the units of standard deviation. The value that you get, now that unit is same as the data. So the formula to calculate standard deviation is under root of var. Under root of where is the formula to calculate this thing. So we will take the same example again. Here we take this 4 7 10, right? So now mean is what? Mean is your 7, and your, if you calculate the standard deviation, sorry, not standard deviation, we, if we calculate the variance, you got the value as 6. You got the value as 6. Last time we calculated, we got the value as 6 here. So this standard deviation will be root of 6, which is the value of this. Let's say if you got the value, root of 6 means some 2.1 or 2.2 something something you will get. So this particular value that you got is nothing but the standard deviation. Its units equal to data units. So that's why we prefer standard deviation. Sorry, we prefer standard deviation over the variance. So I hope you understood the value. It is the square root of variance which represent in the same units as the original data. See, same units as the original data, making it more interpretable. So that's why to say, calculate the same standard deviation, what it has done, just calculate this thing and put under root in it. So I will also write the same formula, 1 by root under root of I is equal to 1 to n. Here we will write xi minus mu the whole square. Just we will put under root. Then you get the value as standard deviation. So now here we calculated it for the population data. Here we again calculated for population data. That's why you got the variance as 6 for this data. And for sample data you will be using this particular formula. For population you will be using this particular formula. He has calculated it for the sample data because here n will be 2, and if you divide it 18 by 2 you will get the value as 9, and if you take under root you will get the value as 3. So like this your standard deviation concept works. So from this entire two lectures, what did we study till now? We studied what is range, means maximum minus minimum value. Percentile we studied this formula. For exclusive we studied it, and I also taught you about the interpolation. For inclusive also we studied it in the last lecture. Quartiles we studied, we divided data into four halves. And sample variance means what? This like to calculate this particular sample we will be using this thing. Population means instead of n minus 1 we'll just keep the n. Sample standard deviation means what? Under root of s square means we'll get the value of variance. So from this, what are the insights that you got? Simple measure shows data spread and position within the distribution. This is what your range and percentile shows. Quartile means what? Divide data into four equal parts using the percentile calculations. Variance and standard deviation measures the average deviation from mean, essential for understanding the data variability. Means how much distance is this data from mean will be tell by this particular thing. So these dispersions are fundamental tools in data science for detecting variability, identifying outliers. So here entire we will be dealing with the nearby points. In central tendency we discuss about the exact center point. In dispersion we deal with the nearby values. So that's it guys, I hope you understood this lecture. In the next lecture we will implement all of these concepts in coding approach. So that's it guys, please do like, share and subscribe guys.